Hello, welcome back. In this video, what we'll be doing is to implement always on availability group databases. Among that, we're going to be doing a lot of different little bits and pieces here and there. So I have identified some of the things that we'll be looking at. So first of all, we will create additional databases, because don't forget, this is about failing over multiple databases in one shot. Unlike in database mirroring, where the failover happens or it's targeted at just one database, always on availability group not only is able to fail over the Windows server, because it is built on top of Windows Server failover clustering, you also have that added functionality whereby each databases can be failed over. So databases that you configure for always on can fail over as a group rather than as one database. So the instance itself can fail over to a secondary server. But again, in the case where the instance or the server does not fail over, you can have only databases to fail over. So we'll see that in action in this particular video. So to get on with our experiments and discoveries, we will generate some data to work with. We will identify some of the prerequisites depending on what we're trying to do, but on a very high level, in simple mode, or let me put it straight, because sometimes you have a very complex setup that the set of prerequisites that you need to ensure that are considered will be different depending on the circumstances. So for example, if you have TDE implemented, the prerequisites you will consider will be different from when you do not have prerequisite TDE. So what we're saying in essence is for a vanilla installation or implementation like ours, we don't have TDE, we don't have SSL, we don't have some other advanced features. On a very simple and vanilla kind of implementation, we have just bare 2 steps prerequisite that we pretty much need to satisfy. So one of which is the database must be in full recovery mode, and also we need to take the full backup of the databases before we can actually configure the databases in always on availability group. And next, we will configure availability groups in synchronous mode. So we have in the previous video discussed what we mean by the availability modes, which we have the synchronous and asynchronous mode. For our own example, we will be doing synchronous mode. In your own lab, I recommend that you practice both, but it's the same steps. I'll show you the steps, but it's just a matter of selecting what option you need to you want to satisfy, be it synchronous or asynchronous. So when we get to that stage, you will see it. But in your own case, try to configure much more than 2 node cluster and test different modes and see how they work together. And we will connect using the SQL listener. So there's the listener. We talked about the listener at the very start of the series, where I told you about the virtual IP layer that you pretty much have to connect to, rather than connecting to primary or secondary. You connect to the listener, and the listener handles which server is active at the point in time, so that it can reroute the connection to the active instance, or depending on whether you just want to read and you have configured a particular server to accept read connections, the listener is in charge of doing the rerouting such that it can reroute the connection to the destination depending on what it's the client is trying to do. Then we'll have a look at the always on dashboard. So there's a dashboard that shows us the health of the cluster or the nodes or the databases. If there's any that requires critical attention, it's in a critical stage, it needs some kind of attention, you can see it from the dashboard. So without having any third-party monitoring tool, you can still use SQL Server Management Studio to do some monitoring around the health of your always on cluster. Then we're going to test the failover, see if what we've been trying to do actually works. All right, so let's get to it. Okay, so I'm going to be doing most of my work from the secondary server. All right, to save a lot of time, I have already written out some of the scripts that we'll be using, so we don't have to type them out and waste some time. So I'm working from the secondary server. I have connected from the management studio to both secondary and primary. At the minute, what we already have is just one database that we created from the start, which is the AOAG_DB database on the primary server. So what we'll be doing, as you can see on the secondary, we do not have any secondary, and what we want to do is create more databases to prove that we can fail over not just one database, but we can fail over a group of databases in one shot. So I'm going to run this. I want to make sure I run this on primary, and we have one database on primary ready, so I'll just execute this command. And after that, we would have to generate some data. So I have a script here. This script is going to be available to you. It was actually written by one of our students in the course of the training. So I decided to use the scripts to load some data. So I will load the data first into the AOAGDB and ensure I'm connected to primary, and that should work. I'll just add one because I've pretty much added numbers in front of the database, as you can see. Okay, so there is no one, it's just 2. So going from 2, put some data in 2, 3, 4, and 5. All right, so I have loaded the data in all the databases from AOGB_DB without a number up until 5. And if you click on the tables, you can see we have some data in there. As you can see, we have all the tables in all the different databases. So these are the different data. All right, so next thing we want to do is we want to identify some of the prerequisites. So we just want to make sure that the databases are in full recovery mode, and we'll take full backup as well. Let's go back at secondary, and to actually I have the property up already to save some time. So to get the properties, just right click on the database and go to properties, and once the database properties dialog box shows up, go to options and recovery model. Make sure that it is in full recovery model, and that's one of the prerequisites satisfied. So by default, all my databases are in full recovery model, so that's fine. The next thing I want to do is to take the backup of each of these databases. So let's see the content of this directory first and see if we have any files there. As you can see, this folder is empty, so it has no backup file at all. So let's hit on run to generate backup. Okay, so we have our full backups now written to, and mind you, even though I'm on secondary, this backup is running against the primary server, and I have connected to the file directory on the primary server, and I was able to do that. Let me show you how I did that actually. So if you go to run, and if you do // the name of the server, primary, // then the name of the partition you want to go to, which is E, and then with a $, and hit OK, it will take you to the E directory. So it's just like going to the primary. Okay, so I'm on primary right now, and if I go to E, and you can see this folder right here is what I have directly connected to from secondary. So take note of that. You're going to be using this a lot in your production environment. So if I go into that and backup, and these are all the backup files. All right, so the next thing we want to do is now to configure availability groups in synchronous mode. Let's go back into secondary and let's minimize this and minimize all these databases. Okay, so we have some room. All right, so what we want to do is go into always on availability, always on high availability. At the moment, we don't have any availability group configured. So the databases are the availability groups. So that's why it's called groups, because we're going to now configure group of databases in always on a high availability. So the first thing we want to do is right click on the always on high availability and create a new availability group using the group wizard. So we'll wait for the wizard to come up. Now that it's up, we just hit on the next. Specify the name for the availability group. In our case, I could just call it Endpoint AG. Endpoint availability group. Cluster type. So we already have a Windows Server failover clustering configured, and you can have this database level health detection specify for you, which is a good thing to have. And by the way, let me quickly make a note here. Always on what was actually introduced in SQL Server 2012, and this is something I'll highly recommend for you to do, is to try to implement this same solution that we're doing in 2012 version and 2014 version, so that you have the experience in all these different versions of SQL Server. So in previous versions, this option wasn't there, and that's because SQL Server would not be able to detect database level health. It's just going to look at health on the basis of the group, right? On the basis of the availability group, not per database. So bear that in mind. But this is a feature that has been introduced in 2016, such that it can now detect the health of individual databases. So bear that in mind. So this is one of the differences between the older versions and the newer version, which is the 2016 version at the time of recording. It's 2017 now, and 2016 is still relatively new, because generally speaking, when new softwares like these are introduced, before most companies begin to use them, the version would have been in existence for at least 2 years. So any company that you find today at 2017, most of them are still using either 2012 or 2014. Before 2016 will become very much in use, we're looking at some are using it at the moment, but very, 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 very few right now in 2017. So by next year and in 2 years time, you see a lot of people now coming into 2016, which is one of the reasons why I have decided to do this training in 2016 to prepare you even for the future, especially if you're watching this video at this point, at this time. But if you're watching it in a much later time, hopefully I'll have time to make an up-to-date version of this recording. All right, so moving on. Okay, so you would see this coming up. It would have identified all the databases on the server. So these are all the databases. Now look at the status here. It says meets requirement. It meets the prerequisites. If we had not done the backup, if we didn't put it in, if we didn't ensure that it was in full recovery model, you would have seen the option here that says it doesn't meet the requirement. So bear this in mind. So always make sure that you fulfill the prerequisite before you carry on. So what I like to do is specify 2 databases. Actually, we'll specify 3 databases and we'll leave 2 out of it. So just to buttress the fact that you can configure certain databases to be as part of a group and leave others, or create another group for another availability group database. Depending on what you're trying to do, the SLAs for each of those databases may be different, right? So this is where architectural decisions come to play, where you make certain decisions, you make recommendations, you're part of a team, you brainstorm together, and you decide which databases are part of a particular group, which databases are part of another particular group, or whether or not you want to have multiple groups or you just want to have one group. All these are dependent on what the business wants and what the SLAs are. So we're going to assume that given our SLAs and business requirements, we just want 3 databases as part of one group. So we're going to click on next, and at this point we will then specify the replicas. So even though, don't forget, and this I have done on purpose to do this configuration from secondary, and the reason I have done that is just to make you become familiar with working with servers from another server, right? So you can as well do the same thing on primary, but because we've set up the networking in such a way that they can easily talk to each other. So I just want you to get familiar with things like this. So we're on secondary, don't forget, but we are creating availability group on a primary instance of SQL Server. So at the moment, everything we're doing is actually from the primary. Okay, so what it's asking us to do at this step is to specify the replicas. So we had more than one secondaries. This is where we begin to tell it and say, okay, if you have 3 secondaries, you start by adding each one of them as replicas, and that's pretty much connecting to that secondary. So when we're now going to connect to our secondary, all right, so don't forget, again, I keep repeating the same thing because these things can easily become confusing. So even though we are on secondary server, we are doing this configuration from within primary. Now from within primary, we want to connect into the secondary. Okay, all these things are happening on the SQL Server instance level. This right here, this is the server itself, right? But this is just database, the database instance. So we're just connecting to the secondary database now. Okay. That's taking its time, but all right, here we go. Do we have the connectivity? No. Oh, we do. Okay, so we do have our secondary now, and at this point there's a little bit of configuration we have to do based on the things that we've been learning so far. So on primary, what do we want? Now this is going to be the initial role. Don't forget, these roles can change later on depending on what happens. If primary goes down, it switches over to secondary, and secondary becomes primary. Okay, what we have here is just the name of the servers. The role itself can switch around, and by the time the roles switch around, don't forget the server name will remain the same because that's just the name that we gave to the server. Okay, so in the real world, you wouldn't give your servers this kind of name, primary, secondary. No, the naming convention differ depending on organization. So if the name of the company is X point, for example, 3X point, we could have given it something like 3X.1, 3X.2, right? So primary could be 3X.1, secondary could be 3X.2. We don't necessarily have to give it primary, secondary, all right? But the role itself, you would see it coming up as primary and secondary. This was not written by us. So this is what SQL Server is telling us, that the initial role for this is primary and the initial role for this is secondary. Okay, so for the primary, what do we want here? Automatic failover. So do we want automatic failover? Yes, we do. And mind you, it's saying we can have up to 3. So you can have up to 3 different servers which can have this configuration. So on our primary, yes, we do want automatic failover. And if you notice, immediately it checks this box for us that says synchronous commit. And remember from our previous video, if you have synchronous commits, you can have automatic failover. And if you take note of the summary down here, it's saying summary for the replica hosted by primary. It's just giving us a summary of what we're doing up there. So replica mode says synchronous commit with automatic failover. This replica will use synchronous commit, availability mode, and will support both automatic failover and manual failover. So remember I told you it's going to have, if you're using synchronous commits, you can have both automatic and manual failover. And secondary, readable secondary, at the moment we have said no. In the secondary role, this availability replica will not allow any connection. So it's pretty much telling us that by the time the role for this instance switches around and becomes secondary, is it going to have is it going to be able to allow connections to read from it? So you can specify yes or no, or read intent only. So I'm going to do a separate video on read intent only. So at the minute you can just ignore read intent only, focus more on no and yes. So do we want it to have a readable secondary? Yes, we do. Sometimes the business requirements may say no. So all these things you have to maybe have like a documentation, a Word documentation that can just highlight all these points beforehand, and while you're still gathering requirements, you can write the requirement in front of it to say, okay, do we want the primary to have readable secondary, yes or no? So that by the time you're doing this hands-on implementation, you can implement it based on the requirements that you have gathered so far. So similarly on the secondary, what do we want? And if you notice, the moment you click on this, it changes the summary for this particular instance. If I click on this, it's now giving me the summary for this particular instance. Okay, so don't be confused here. So the initial role is secondary, and when the role switches around, what do we want? Automatic failover? Yes, we do. And similarly, we want the readable to allow connections to be able to read it when it switches around, or when it remains as secondary, depending on what's going on. All right, so endpoint, this is going to be populated for us by default. If you're familiar with database mirroring, this shouldn't be new to you. It's the similar things that happen. So each of them would have their TCP endpoint and the port, the default port, which is 5022. So you can bear that in mind as well. It's an interview question. You may be asked that what's the default port for the endpoint URL for your primary and secondary replicas. So the default port is 5022. This can be changed, but depending on the use case, most of the time I've seen it left at the default anyways. All right, so backup preferences. Here it's also asking what's going to be our backup preferences. Do we want the backup to be taken on the primary, or do we want it on the secondary, Or do we just want to tell it, okay, we prefer it to be secondary, but if the secondary is for some reason unable to take backup, then you can take it on primary, right? So it's just some level of flexibility and load balancing, so that if you don't want to take backups on the primary, you can dedicate one of the replicas to take the backup for you and remove the load on the primary from taking backup. So you can imagine if the database itself is about maybe 1 terabyte or 500 gigabytes, which is quite a lot. Taking backups can take like days. Some backups can take 2 days, 24 hours, right? And when these happen, it's resource intensive, it's IO intensive, and it can actually become a bottleneck for users that are using the system. But in a case where you have now offloaded this load onto the secondary, especially a secondary that is configured in synchronous mode, it is always synchronized with the primary. So that means it has an up-to-date replica of the data from primary. You can pretty much configure that to be the instance that will be doing your backup. So here you can say, okay, I want the backup to happen only on the secondary. Well, for some use cases, they may say yes, we want it to have it on the primary, but it's good that the option is there, but you hardly ever want to do this, because what's the essence of you having the secondary and then taking backups on the primary? And here you can specify any replica, and with that you can then say, okay, what's the ratio of the backup priority? So here is 50-50. You can specify the numbers 70 30 80 20, depending on the preference, who you want the backup preference to lie on more. And Microsoft has done all the algorithm in such a way that it understands the ratio, and it can, depending on the load, if it sees that the primary, if it sees, for example, that the secondary is much more busier than the primary, and you've configured the backup priority in such a way that the algorithm works out that primary is best fitted for backup, it would just dynamically go to primary and take the backup there. And if you want, you can exclude a particular replica from taking backups. So if you click on this, you can see this has been grayed out completely. So all these options you can do. So in our own case, I'll just say I prefer secondary for the backup. So the backup preference, you can then still specify numbers and say, okay, on the primary I want it to be a case of 80 to 20, so that the backup will tend more towards the secondary. Okay, now listener, this is the part where we create that virtual IP or DNS name that we can connect to, just like we connect to secondary. So for example, if we were to connect to an instance, we wouldn't connect to secondary or primary. We'll just specify the listener name, whatever name we give to it. So for example, we're going to use something like Endpoint listener, Endpoint listener. So I'll just copy that, and if I hit on connect, you'll see that it will come back with an error saying it doesn't exist or something. You see, it has actually gone to query the DNS, the network. It says the network path was not found. It doesn't exist. A network related or instance specific error occurred while establishing a connection to SQL Server. So it doesn't exist. It's not aware of it because we haven't created it yet. All right, so we'll come back to that. Let's go back to our wizard, and now we will specify the name Endpoint listener, and 1433, that's the default SQL Server port. You can specify a different port if you want. In our own case, I'll just give it 1433. And here, if you hit on add, this is where you can specify the IPv4 address. If you take note, we have two network interfaces, and let me show you how that came about. So if you go to failover cluster manager, remember our failover cluster, Windows Server failover clustering that we implemented before. Okay, and if we go to networks, you can see that we have two network interfaces here. So cluster network 1 and 2. So if you go to 2, for example, you can see 192.168.1.0. remember when we were configuring our network interface, and this other one was the one that we created. Remember when we added additional network interface? Let me go to primary, for example, and we went into the manage virtual machine settings, and we went into the network adapter. Remember when we had this NAT, which allowed us to go to reach the internet. So these are the two network interfaces, and that is what SQL Server has picked up here. So that's exactly the same thing that SQL Server has picked up here, saying you have two network interfaces. So you can now create your listener based on whichever one you want to use, basically. So I'm going to use the 192.168.1 with the network subnet mask of 24, and here is where you would work with your network administrators or systems administrators. You work together and they will give you the IP address that is suitable. You tell them what you want to do. You want to create a SQL listener. They should give you, among the IP ranges that are available, they can give you a static IP address that you can use. So I'm assuming that they've given me an IP address that's available that I can use, and I would use some like 192.168.1, and the let's see, let's go into IP config. Okay, so here, okay, right, so these are the two network interfaces. So this is the 1, this is 0, 0 and 1, Ethernet 0, Ethernet 1. So on the command line, it's a different name you see, Ethernet 0 and 1. So Ethernet 0, which is the first one that was created, we have 192.168.1.132, right? And that's the one I want to use, create the listener out of. Okay, so it's 192.168.1.132, and I believe the primary is 131, if I'm correct. So I'll just use something around there. I'll use 143. I know 143 exists, so that's fine. All right, and that's it. Okay, now we can hit on next. At the next stage is where we will just give it some information. So what's going to happen is, remember, these databases exist only on the primary. They don't exist on the secondary, and I'd shown you that before. So let's have a look. So let's cancel all of that. On secondary, you can see we don't have the databases here. I'm going to refresh, and you see it doesn't exist, but on the primary the databases exist. So now, for each of the databases, it requires the MDF and LDF files. SQL Server needs to understand how to create these on the secondary. So you have an option here that says automatic seeding, and this pretty much says, okay, I'm going to create these databases on the secondary, but please make sure that if you're specifying this option, the partition are exactly the same. And this is what I mean by the partition. The data and the log. So if data is E on one server, data has to be E on the other one. if log is L on one, it has to be L on the other one. The drive letter and the name and everything, and where the databases would exist, just make sure it is the same. Otherwise, it will run into some errors that you wouldn't like. And if you were to give this option, all you need to give to it is a network share that is accessible to both. Remember, we used a file share server before, and we just created a folder and shared that folder. You know that share address, you could just copy it and paste it here for the folder that you dedicate for this purpose. And if what you've done is you've manually created the databases on the secondary, okay, so there are use cases for each of these. So for example, if we had TDE configured, TDE is the transparent data encryption. The way AlwaysOn availability groups databases are implemented is a lot different, and I'm going to do a separate video that shows how to do that as well. In that case, you would consider an option like join only, so you have already done most of the heavy lifting yourself and you're just going to join the databases together. If you don't want to do any synchronization at all, you can skip it altogether and do that later. So there are use cases for that as well if that's what you want to do. In most cases, you either use this or this, so either automatic seeding or full database, where you specify a network share that is accessible to all of the replicas. So in our own case, I'm going to use this one because I know everything is identical on both servers. So I can hit on next. And as you can see, it's going to run some validation check. The first one is going to check for free disk space. It's going to check if the selected databases already exist. So depending on what you selected before, if it doesn't exist already, it's going to have to create it for you. It's going to check the database file locations, how compatible they are. Remember, I mentioned the compatibility. You have to make sure those are fine. It's going to check the existence of database files. So if the database files already exist, it's going to have to deal with it somehow, either through an error or tell you it's success. It will check whether the endpoint is encrypted using compatible algorithm. It's going to check the replica availability mode settings that we specified. It will check the listener configuration, and all of these things is actually going to post some data into these clustering Windows Server failover cluster console. So if you go into roles, by the time we hit and execute, you'll see the AlwaysOn availability group that will be created in the roles section. So let's just hit next, so that all the validation that we ran before will now actually be implemented. And just you have an option to script everything. So if you want to see all the statistical code that will be written, that will be applied, you can generate it. Actually, I can do that so that you can have a look and have a feel of what it looks like. And there's reason why you want to do that. So if you want all these things to be automated, right? So there are times that you would have no reason to manually do these things, like use the wizard to create all these things. If you work in like a DevOps kind of environment where things are automated, you use PowerShell and things like that, you want to use this script. Even though you can see it's already giving us some res quizzly, you can go to query and use SQL CMD mode. As you can see, it's going to change and everything is going to be fine. So there are ways to use all these kind of things. It's beyond the scope of this particular training, but I will have some time to do create some advanced database administration videos where you see how these things can actually be automated using PowerShell without using the wizard at all. Just run a script and everything is being implemented for you. So I mean, this is something you want to consider for the future, but it's cool. Not all requirements require that at all, and it's not as difficult as it may sound. Okay, so this is good enough for even senior level DBAs. You still use the wizard. All right, so we hit on execute, and let's look at the roles. You see how SQL Server will start communicating with the cluster, the Windows Server failover cluster. It's going to query the DNS. It's going to add some, you can click on more options to see the progress, and you will see it's going to actually talk to the domain controller. It's going to put some DNS record there for the Endpoint listener. The IP address is also going to be registered in the domain controller. You know, within domain, all these things are going to happen, but SQL Server is very nice to us, as everything will be done for us. You don't have to do any coding. All you have to do is know what you're doing, specify all the configuration that you want, and you'll see all the things happening behind the scenes. So now everything is completed successfully, and as you can see in the roles section in our Windows Server failover cluster console, we have the Endpoint that's got AG that is now being configured right there. So we didn't have to do it. It's basically done it for us. And as you can see, the client access name is the Endpoint listener, and the IP address is what we specified when we were creating in the wizard. All right, so let's go into the primary, refresh the whole thing. Okay, refresh secondary as well. Now if we go into, let's start with the primary. If you go into the always on high availability and go to availability groups, now we have Endpoint underscore AG, and it says it's the primary. Okay, how many replicas do we have? There are two replicas, the primary and the secondary. Availability databases, how many do we have? We have 3 databases. And on the server, how many databases do we have? We have 5 databases. So you can see we have 3 databases configured in a specific group. So just similarly as we have created this group, you can right click, do a new wizard, create another group, and you'll see its own node come under that. You can give it a different name. So you see, so we have this particular group and it has its own listener. So if we use this it listener now to connect, we'll be able to see the databases for this availability group. So let's try that. So we'll specify the listener. And boom, there we go. Our listener is connected. You can see if we expand the databases, it's a little slow just because of the resources we have on this server. So now we're connected. Even though it's showing us all the 5 databases, it's showing the 3 that are part of the availability group and its state, which is synchronized. And remember, we talked about this synchronized state when we talked about the availability replicas. So because we're using the synchronous mode, the databases will always remain synchronized. If we go into secondary, you'd see everything is green, the databases are synchronized, and we're good to go. Now, bear in mind, depending on the resources you have on your computer and the size of the database, obviously, this might actually take a while. So if at first you don't see these databases there and you see like a yellow warning sign here, just give it some time because the databases are probably being created. It has to wait to transfer the logs and catch up basically with the primary. So just give it a while, except you run into error. If there was any error, you would have seen that, obviously. But we're good, no errors, and now we have our always on availability group databases configured. In the next video we will start playing around with it, and we'll continue with the training. All right, see you in the next video.